Hi there. Yeah, as Claudio said, I'm George. I'm a blockchain architect and co-founder of LimeChain. And one thing that we have been working on for I guess, the past 4 months as part of Ethereum Foundation research is around the concept of base rollups, base sequencing, base preconfirmations. And we were able to come out with, let me see how do you change slides, Claudio? Claudio, can you help me with changing slides?
Yes.
Is this thing?
It's this thing, and this is probably, try the green one.
Okay, yeah, it worked, okay. Yeah, so what we came up with is what we believe is the most complete decentralized rollup design proposed to date that is based on base sequencing. What's base sequencing actually? It is okay, yeah. And yeah, so it's based on the original concept by Justin Drake for base sequencing. What's base sequencing? Maybe just as a quick recap. Base sequencing is a concept for rollup architecture where the sequencing is driven by the L1 proposers themselves. What you can think of this is that instead of you building your own algorithm for sequencing or decentralized sequencing, instead of figuring out your own validator set, what you can do is you can actually outsource this duty to the L1 proposers and reuse the economic security and liveness properties of the Ethereum L1 mainnet. And yeah, so today we're going to review 4 of the properties of vanilla-based rollups. Some of them are applicable for plain-based rollups. Some of them are specific for vanilla-based rollups. And yeah, and happy to answer any questions after that. And these are the 4 things that we are going to try and figure out and talk a little bit about. Let's start with the decentralized stuff. And I'll actually go on a little bit on a tangent here and talk a little bit about centralized sequencing. And I have a controversial opinion, and this opinion of mine is that actually centralized sequencing is quite cool. And it's cool because it actually drives massive efficiencies. If you ask the regular user that doesn't care about the tech, centralized sequencing they don't care about, whether it's centralized or decentralized, because you are getting offered massive cost savings, you're all getting offered massive efficiency gains in terms of speed, so you get stuff like pre-confirmations very easily. And yeah, so centralized sequencing is cool, can be cool. Regular folks probably wouldn't care whether it's centralized or decentralized, and this is normally the case with any centralized versus decentralized system until shit hits the fan. And this is where I guess us, the decentralization believers, tend to kick in. This is where we start our work, because we know that whenever there is central point, there is also a possibility for all the downsides that come from monopoly. There is possibilities for censorship and yeah, unfair competition. So we started our thing with, and don't squint, this is purposefully not readable, but the idea is that we actually explored all the various facets that a rollup can actually decentralize its sequencing. And we were able from first principle to come out with the idea that base sequencing offers unique properties. And these unique properties are going to be very hard to replicate by other decentralized sequencing designs, and this is why we pursued and continued pursuing base sequencing. But yeah, we kind of quickly realized that decentralized sequencing got hands and it's very hard to actually design decentralized sequencing. But tried and came up with this thing that's called vanilla-based sequencing. What's vanilla-based sequencing? It is an iteration of the original base sequencing concept. So just as a quick recap, base sequencing is the form of sequencing where you essentially give the right to the L1 proposer to be your sequencer. The problem with this version of base sequencing is that you require the L1 proposers to opt in to sequencing your rollup. which means that you'll have a lot of time slots and a lot of L1 slots where you might not have the L1 proposer opted into your rollup. Therefore, you'll have no sequencing, which is worse than centralized sequencing because you have no sequencing. You might even go for epochs, especially if you think about the early days of a rollup. You will have a cold start problem because you can have an epoch upon epoch where you have 0 proposers that have opted in to be your sequencer. So you might not even ever know when is going to be your next sequencer. So then you start worrying, oh well, where do I send my transactions? How do I keep my transactions until a sequencer appears? All these things. So the first improvement of vanilla-based sequencing compared to based sequencing, to the plain-based sequencing, is the notion of fallback proposers. Essentially, what we suggested in our research here is that if the current L1 proposer have opted in to be your rollup sequencer, then give them the rights. But if they haven't, let's actually choose one of the opted-in proposer at random and give them the rights to be your sequencer. And what we argue in here is that this actually is a great way to tackle cold start problem, because this is a massive revenue increase for the opted-in L1 proposers, that for opted in as sequencers L1 proposers. Because unlike with L1 where you get 3 times a year per validator to be a proposer at best, with this system, the less opted-in proposers there are, the bigger the chances that you are actually going to get drawn to be a sequencer, and then you get drawn to be a sequencer, the obvious good things happen. You get transaction fees because you're doing service for the rollup. So this actually very nicely tackles the cold start problem. If there are few opted-in proposers, then the few opted-in are going to be making massive profits, and then others are going to notice these massive profits and say, well, I want part of this. So they're going to start opting in, and we end up with the property that we actually desire, which is high participation of L1 proposers. Great. Then, going a little bit back to the pre-confirmation, to the centralized sequencing, one thing that currently rollups with centralized sequencing can offer and is now a de facto standard is pre-confirmations. Current version of pre-confirmations is reputation based. So Optimism sequencer, Arbitrum sequencer, they can offer pre-confirmations on the merit that if they start reneging on these pre-confirmations for whatever reason that is there, then this is going to hurt massively their project. In a decentralized setting, you cannot actually have such a reputation-based pre-confirmations, and you need to start figuring out how do we do that in a decentralized setting. But the more important message, I guess, in here is that you need pre-confirmations because users actually, they expect that. They want to be able to know within a matter of hundreds of milliseconds that their transaction is going to go through, and ideally what their result of their transaction is going to be. So we actually designed this inside the system. It's a two-step system. What we propose is introduction of new transaction types for rollups, which are pre-confirmation transactions, which is new type EIP 27, whatever it was, the transaction type thing. So new transaction types that are for pre-confirmations. We actually examine 2 types of pre-confirmations. Inclusion pre-confirmation, where you just need a confirmation that your thing is going to get into the next block. And also execution pre-confirmation, which is something quite cool, especially for arbitrageurs and bots, which is you constraining what you want for the sequencer to confirm that the state after your transaction is going to be. So maybe this is a specific trade that you want to make sure is going to go through. And what we're proposing here is actually cryptography-based pre-confirmations that require 2 steps. First step is requiring submitting a pre-confirmation transaction, and then the second step is actually a commitment from the sequencer that whatever they are pre-confirming is actually going to go through, and if it doesn't go through, they're going to get punished. This commitment is in the form of signature of what they have pre-confirmed. Third interesting property, proposer-centric design. Again, this is hard to read. It's not it's not my intention for you to read all the different boxes that are there. There is a white paper for vanilla-based rollups that all of this is explained in much more details, and if anyone is interested in this can see. What I'm trying to illustrate in here, that in the heart of the system are actually the proposers. And this is what I mean by proposer-centric system. The proposers receive the L2 transactions, they act as sequencer, they bundle these transactions into L2 blocks, and then they pass these L2 blocks as L1 transactions to the current existing L1 pipeline through the relay and through the builders. In order to be able to achieve this, first of all, we suggest that originally in the paper a software that's called GMAV Boost. G stands for generalized. And the purpose of this software is to offer two things. First of all is to offer the ability for L1 proposers to have new inputs of transactions, of streams or conditions. And the second thing that this software does is uses something that we are suggesting here that's called Conditions API. And Conditions API is an extension to the Ethereum Builder API that adds the ability for a proposer to constrain the bits that they're willing to accept from builders, which essentially means that the proposers can create pre-confirmations for L2, they can create blocks which are essentially L1 transactions with blobs, and require the builders to provide them with blocks, to build them blocks that actually honor these conditions in the inclusion of this transaction or multiple transactions. Recently, there has been an initiative that's called Commit Boost. So we have decided to actually join forces with the people from Commit Boost because we are essentially building the same thing. And Commit Boost is essentially a software that is a framework for proposers where different modules can be used. And these modules can be, for example, this GMAV stuff. You can run plain old Mav Boost, or you can start overloading the proposer with the various other functionalities that you want to see there. Alternative to proposer-centric design, and why we believe that this is very important, would be builder-centric design. And the difference would be, where do sequencers and proposers submit transactions? Who's responsible to enforce that these transactions are going to end up within the blocks? And we believe that the better suited actor for this is the L1 proposer, because the L1 validator set is huge, diverse, and decentralized, whereas in practice the current builder set is of single-digit entities. And the problem, if you are going to be basing the critical path of communication for your sequencing transaction on a single-digit entities, is that you actually end up with something that's, I guess, metaphorically known as the Godfather problem, that these single-digit entities essentially need to become the godfathers of your rollup in order for your rollup to even exist. This is a problem that was seen in other L1, I guess, ecosystems, where in order for you to launch your own network, you needed to have the blessing of certain limited number of actors before you can actually even launch your own network. So what we try to design in here is to base ourselves on the diversity and the size and decentralization of the proposer and the validator set rather than the builder set. And yeah, this actually leads to my last point, is that especially like this architecture and this suggested design retains the rollup sovereignty, and this is something that we built with it in mind. Because if we enshrine certain actors or certain few individual entities that are critical for the operation of the system, and these are not permissionless, then the rollup is no longer sovereign. And we believe that rollups it should always be sovereign in order to be able to iterate, in order to be able to service to their best the users, because it's only then that we're going to realize the vision of the rollup-centric Ethereum. And then all of this was a research. by the way, there is two companies that are already building on top of this and are building their own rollups for various use cases on top of vanilla-based rollups. And parts of this research is already incorporated in other rollups. We are also creating a proof of concept version of vanilla-based rollups with L2con currently, so that we can help L2con support pre-confirmations and help them move towards vanilla-based rollups design. But ultimately, us as a company, LimeChain as a company, the company that I represent, we are very fascinated by rollup designs, and we would love to learn more about how you think about building your rollup, how the company that you represent thinks about decentralization, if you're representing rollup and all these things. So what we want to do is essentially talk with all the rollups and pick their brains in terms of decentralization. And yeah, so this was everything that I wanted to share for today. Much more of this is available in, I guess, research paper form. I hope that I sparked some interest there. Open for questions.